In this video, I will walk you through this optimization problem. Which points on the graph of y equals 4 minus x squared are closest to the point 0, 2? Here's a picture of the graph of y equals 4 minus x squared off of Desmos, but you should be able to draw a rough sketch of it yourself because y equals 4 minus x squared is the same as y equals negative x squared plus 4. We know this is a parabola that is downward facing because we have x squared with a negative in front. That's what makes it upside down. And we know that the vertex is shifted up 4 because of this plus 4. So we know that the vertex of the parabola would be here at 0, 4, and then it would be facing downward. So you could have drawn this sketch yourself. Here is the point 0, 2. We are supposed to locate the coordinates of a point on the parabola that is as close as possible to 0, 2. So I don't know, maybe it'll be here, but they said which points plural because of the symmetry. If there's a point here to the right that turns out to be the closest, then there will be a corresponding point on the left. So this problem should have two solutions, one on the left and one on the right. So we need to find what these coordinates are. So let's call this one over here on the right, let's call this x, y. But whatever this one turns out to be, I'm betting there will be another point that is the opposite of x, y. All right, but we'll just let that sort of take care of itself. So in fact, let's just focus on the right-hand side and let's find this point xy that is as close as possible. In fact, let's just ignore the left-hand side. So let's stick to the first quadrant. We know there's going to be a point over here somewhere. So if we get a plus or minus happening, let's just stick with plus because we know there will be a close point over here. And then we'll know there'll also be a negative one. We can just figure that out by common sense afterwards. So what will the primary equation be? What are we trying to minimize? If we want this point to be as close as possible to 0, 2, that means we need to minimize the distance between these 2 points. So let's set up a formula for the distance. That's right, a formula for the distance is the distance formula. This is a formula that will not be given to you, so make sure that you have it memorized. The distance between 2 points will be x2 minus x1 squared plus y2 minus y1 squared, where x1 and y1 will be the coordinates of one point and x2, y2 will be the coordinates of another point. So in this case, we have the 2 points. We have 0, 2 and x, y. So I will substitute those values into the formula. And then we get the following expression. The square root of x minus 0 squared plus y minus 2 squared. Okay, on my next step, I will ignore that 0 and pretend like it's not even there. But anyway, this is too many variables. We need an expression that only has one variable. So we will need a secondary equation. In this case, they just plain gave us the secondary equation. It is y equals 4 minus x squared. So let's do that substitution and put 4 minus x squared in for y right here. So there it is. I put 4 minus x squared right where the y was a minute ago. I do see some like terms in here. There is a 4 and then minus 2. So that'll just be a 2. We can't really simplify it any further than this. So this is the equation that we need to memorize. This is the equation that we need to minimize. Normally I would take the derivative of this and set it equal to 0 to find those critical values. And I could do that, but this would be a relatively ugly equation to find the derivative of, just because I have this the square root over everything. So this whole thing is to the 1/2 power, and then I've got the x squared, plus the 2 minus x squared squared. So there's a lot of chain rule going on. There's an easier way. There's a shortcut that I can use. My strategy will be to minimize just the inside part of the radical instead of taking on the entire thing. So this takes a small intuitive leap that I hope you can follow with me. We are looking for the x value that will make this whole expression as small as possible. But what if instead I minimize the following expression? I'm going to call it I for the inside part. Very clever, I know. Thank you. So the inside part is x squared plus 2 minus x squared squared. So imagine that we find the x value that makes this inside expression as small as possible. Well, if we're making the inside as small as possible, then if we stick a square root on that, the square root will still be as small as possible, right? So if we find the x value that makes the inside part the smallest number possible, then that same x value will automatically make the entire square root as small as it could possibly be. So I hope you followed that. So I am going to use that shortcut. So I am going to end up finding the derivative of this expression and finding those critical values. So here we go. Let's do I squared, not I squared. Let's do I prime. And so here we go. That's going to be 2x. And then here I do have a little bit of chain rule happening. So this 2 is going to come into the front. And then I'll have 2 minus x squared. But because of the chain rule, I need to now multiply by the derivative of the inner function. Don't forget the negative sign. So this will be times negative 2x. So this is I prime. I see that we have 2 times negative 2x. So this will make negative 4x. So I have I prime is equal to 2x minus 4x times 2 minus x squared. Let us distribute the negative 4x across these parentheses. So I will have I prime equals 2x minus 8x plus 4x cubed. Now I can combine these like terms. So 2x minus 8x is negative 6x. So I have negative 6x plus 4x cubed. All right, now I'm just going to change the order a little bit. No, I guess it doesn't matter. I am going to find out where I prime is equal to 0. That's the next question. We know that a maximum value can only occur at a critical value. So that's what I'm trying to do. I found I prime, and now I'm going to find where I prime is equal to 0. So setting this equal to 0, I have negative 6x plus 4x to the third power is equal to 0. I think I'll factor this. I think I will write this in the proper order. So I have 4x to the third power minus 6x is equal to 0. And if I factor out 2x, all right, that's my GCF. So if I take out a 2x, then I have 2x squared minus 3 is equal to 0. Setting each of these factors equal to 0, I have 2x equals 0, and I have 2x squared minus 3 equals 0. From this first little equation, I get x equals 0. Over here, adding 3 and dividing by 2, I get x squared is equal to 3 over 2. which means that x is equal to plus or minus the square root of 3 over 2. For these optimization problems, if you only get one critical value, then that critical value is the answer. However, if you get more than one, you have to do a candidates test to decide which critical value leads to the max or min, whatever you're looking for. In this case, we found 3 critical values. We need to go back and plug each of the 3 critical values into the primary equation to see which value actually leads to the minimum. Let's use this version of the equation because it already has only one variable, and that way we can just plug in x rather than substituting x's and y's and having to figure out what the y value is separately. Let's just use this version. Let's start with x equals 0. If we substitute that in, we will get 0 squared plus 2 minus 0 squared squared. So let's see. The 0 squared, that's gone. This 0 squared over here is gone. So I have the square root of 2 is all that's left. Well, 2 squared. So I'm going to have a 4. And of course, the square root of 4 is 2. So that's one value. And I mean, we could see this on our picture, actually, because at the point x equals 0, we are on the point 0, 4. So we knew that the distance here is going to be 2, all right? But hey, we're doing a candidates test. So let's go through these motions. What's next? Next, let's do the positive radical 3 over 2. So let's try an x value of positive radical 3 over 2. It's going to be a little bit cumbersome, so bear with me. I think I'll have to make it kind of big. So I have x squared. So I need to do radical 3 over 2 squared. All right, plus 2 minus, okay, and then I'll have radical 3 over 2 squared squared. All right, very awkward, but this does simplify down fairly nicely because when you square a radical, the radical goes away. So I still have this whole square root, but right here, the squaring makes the radical go away. So I just have 3 over 2 plus 2 minus. I'm squaring this radical right here. Again, the radical goes away. So I will have 2 minus 3 over 2. And that whole thing is being squared. I think I'll do one more step right here. To make like denominators, instead of having a 2, I can write 4 over 2. All right, that's the same thing as 2. But that way, on the next step, I can add those together. So let's see. I'm going to have 3 over 2 plus 4 over 2 minus 3 over 2 is 1/2. So I have 1/2 squared. And then I have the square root of 3 over 2 plus 1/4. Okay, but if I want to have like denominators, I'm going to have to multiply this by 2 over 2. All right, so that'll be 6 over 4. So on the next step, I have the square root. I have 6 over 4 plus 1 over 4, so that's 7 over 4. So I have the square root of 7/4. All right, just out of curiosity, I am going to come up with a decimal approximation for you. Well, okay, before I do that, the square root of 7/4 is the square root of 7 over 2. That's not approximately. That's equal to radical 7 over 2. When we plugged in 0, we got 2 for the distance. And now we have radical 7 over 2. So we need to decide, is radical 7 over 2 closer or further away than 2? All right, is this more or less than 2? Here's how you can compare 2 versus radical 7 over 2 without a calculator. First of all, let's make them like denominators. So I could multiply this by 2 over 2. So that's going to turn this into 4 over 2. So now I have 4 over 2 versus radical 7 over 2. Now let's make the numerator of this first number a radical so that we can compare directly. So 4 is the same thing as the square root of 16. So we have the square root of 16 over 2 versus the square root of 7 over 2. Obviously, the square root of 7 over 2 is less. And remember, we're trying to minimize the distance. So smaller is better. So the radical 7 over 2 is winning. I'm going to put a little frowny face next to 0, 2 to remind us that we already know that this is not the answer. So we have one last candidate to test, and it is negative square root of 3 over 2. I'm going to set this up, but I'm hoping that we can use our work from the previous problem to make this shorter somehow. Yeah, so here's how we can use our previous work to make this shorter. Notice that as we make the one change of the square root of 3 over 2 is now negative. But in each case, the negative radical 3 over 2 is being squared anyway. So this will immediately give us the same thing we got the last time, because when you square it, it's going to turn positive anyway. So the negative sign is not going to change anything. So that means that we are going to get radical 7 over 2 again for this one. And we don't have to show all of this work. We just know it's going to come out to be the same thing. So that means that we have two answers, and we knew we would because of the symmetry. We knew we would have one on the right and then one on the left. But now we know what they both are. Well, at least right now we know what the x values are. We still need to find the y values that go with these x values. We can use the secondary equation to come up with the y value. So y is equal to 4 minus x squared. But remember, x was the square root of 3 over 2. Well, that was one of them. The other one was negative. If we square this, the radical goes away. So we end up with 4 minus 3 over 2. And making like denominators, we have y equals 8 over 2 minus 3 over 2. So y equals 5 over 2. These 2 points will have the same y value, all right? We can just tell that visually. Also, we can tell because if we plugged in the other x value, that would mean putting a negative sign right here. But when you square it, the negative sign would go away anyway, and we would get the same y value. So we will have the same y value for both x values. The 2 points closest to 0, 2 are the square root of 3 halves, 5 halves, and negative square root of 3 halves, 5 halves.